Alright guys, so today I'm going to go over your Delta Math assignment today. I wanted to go over it to make sure you understood what each section was asking. So there's 4 sections. I'm going to do 2 examples from each section, and it's kind of like a review of what we've done all week. Okay, right now, the first thing I'm going to go over is selecting an equation from graph roots. Okay, so this is where you look at the graph and you have to know if it crosses or if it touches. Okay, and you have to find the x-intercepts. And if you look down here, there are no a values. Okay, so see there's no a values, so I guess it's an understood a value of 1. All right, always look at your multiple choice to see what it wants. So we don't have to worry about solving for a. So I have 3 zeros. Now double check to see if that's all. You count your humps. I got 1 hump, 2 humps, and it's your humps plus 1. So my degree is 3. So I need 3 solutions. 1, 2, 3. Okay, so I'm good. So everybody has a multiplicity of 1. This is at 0. So we're going to say x minus 0. And where it's opposite, this is at positive 6. So it's going to be x minus 6. This at positive 8. So it's going to be x minus 8. We don't need to leave that as x minus 0. We can just put x. And then x minus 6 and x minus 8. So then you come down here and you look. And our answer is going to be what I would call A. Okay? All right. Another one from there. So this one's a little bit different. Okay? It's the same concept. But how the other ones just, so you saw how the other ones just touch, are crossing. See that crosses. These two cross also. And remember when you cross, you have an odd multiplicity, which is these are all 1, so that's odd. Now, if you touch, you have an even multiplicity, okay? And that's why I tell you to count your humps, because then you know what even multiplicity you need to have. So I have 1, 2 humps. That means this is another degree of 3. Okay, so that means I need my little exponents, my multiplicities, to add up to 3. And so if you look, I only have 2 roots. That's at a minus 4, so it's x plus 4. That's at a positive 1, so it's x minus 1. But at this one right here, it touches. And when you touch, you need an even multiplicity, and I need it to add up to 3. So I'm going to make that a 2, because 1 plus 2 gives me my degree of 3. Okay? Now, it has it written out completely. So this 2 just means that there are 2 of those. So I'm going to say x plus 4 times x minus 1 times x minus 1. And so this would be my answer. Okay? All right, so that is it for a select equation from graph roots. Okay? And it wanted in factor form as the answer choices showed you. Okay? It'll tell you if it wants it in standard form. So this one says the polynomial function is graph below. Fill in the form below regarding the features of the graph. So I need to fill in this down here, okay? So if you look, this is asking if it's odd or even. This is asking for if it's positive or negative. All right, I'm going to tell you a shortcut of how to remember without having to look at that chart, okay? So without having to look at the chart, how do you know if it's even versus odd? Well, even, to me, even means the same. So see how they're both pointing down? That's going to be an even degree. If they were both pointing up, like this, that would also be even, okay, because they're both pointing up. So to me, when stuff is pointing in the same direction, that's the same. It's even. So this is going to be an even degree. Your leading coefficient matches where your arrow is pointing at the end, because it's end behavior. So see how this is ending, pointing down? So that's going to be a negative leading coefficient. See how this one's ending, pointing up? We would say this is a positive coefficient, okay? Let's write that out better. Now, zeros, your real zeros, how many times does it cross the x-axis? Well, it crosses it 1, 2, 3 times. So I have 3 real zeros. Your relative minimum values, that's how many minimum values, like how many mins. So how many valleys? So a max would be a hump. A min's going to be a valley. Okay, so I have one minimum value right there. So I'm going to put 1. All right. And this started the determine the features of a polynomial graph section. So one more. Now the last one was even because they both pointed in the same direction. So odd to me is different. So it's going to be pointing in different directions. Okay, and it could even look like this. Okay, no matter which way it's pointing, if it's pointing in different directions, this is going to be an odd function. Okay, so this degree is odd. Again, it's your end value. Where are you ending? I'm ending pointing up, so that's going to be positive. If I was ending pointing down, that would be negative. Okay, how many real zeros? How many times it crossed the x-axis? 1, 2, 3, 4, 5. So there are 5. This one wants your relative maximum values. That's going to be your humps. I've got 1 hump, 2 hump, and that's it. So I've got 2 relative maximum values. Okay. All right. That's it for that section. Next, I want to write a polynomial function from the graph. Okay. Now, this one, I wish it would tell you like that last one. It didn't want you to solve for the a value. This one didn't, see? So this one actually does want you to solve for your a value. Okay. And anytime, I know this is probably not the best way, but with delta math, you can always show the solution and get a new problem just to see what it's asking for. But I've already looked at this one, and it shows me it does want you to solve for that a value. Okay. So let's go ahead. So this one is going to be writing polynomial functions from a graph, okay? Now it says write in any form. So save yourself from trouble and just keep it in factored form, okay? But if you want to go to standard form, you can. So factored form means you have to get your factors where it crosses or touches. Now, first count your humps. I've got 1, 2 humps, so that means it's a degree of 3. So that means I need 3 roots, but it only crosses 1, 2 times. But if you look right here, it touches, so that means we're going to give that a multiplicity of 2. So I've got x plus 1, and then I've got x minus 4 twice. Now I still need that a value, okay? Now, also another hint that I want you to solve. See how it gives you a point right here? That's the point I want you to use to solve for your x and y like we did in our video from Tuesday. Okay, so that coordinate right there is 0, positive 8. Remember, that's your x and that's your y. So I'm going to plug the 8 into my y, and then I don't know my a, and my x is 0. So I simplify. I get 1 times negative 4 squared. Negative 4 squared is 16. 1 times 16 is just 16. Then we divide by the 16. Simplify it. So a is 1/2. Double check my mind. Yep, 1/2. So the equation I'm going to write down here is 1/2 times x plus 1 times x minus 4 squared. Okay, so all I did was take this part that I had already formed, and then when I solved for my a, I just plugged it into my a value there. Okay, and that's how I got my answer. Okay, let's do another one. All right, so this one wants to do the same thing, write the function in any form. So why not keep it in standard form? It saves you a couple extra steps, okay? All right, so first you count your humps. I got 1, 2, 3, so plus 1. This is going to be a degree of 4. Okay, and I only have 2 intercepts, but they both touch. So that means they're both going to be counted twice because 2 plus 2 will give me that 4. So it's y equals a times x plus 2 squared times x minus 1 squared. All right, now see how it gives you another point right there? That point is 0, 12. So I'm going to plug that in. 12 equals a times 0 plus 2 times 0 minus 1 squared. That's going to give me 2 negative 1 squared. Oops, from equal sign. Negative 1 squared is just 1. 1 times 2 is 2. Then we divide by 2. And a is going to give you 6. Okay, so then I'm just going to take that a, plug it in back up here. So my answer is 6 times x plus 2 squared times x minus 1 squared. All right. All right, so that is how you solve for a in factor form. So the next section we're going to do, I'm actually going to do 3 of these examples. So this is from yesterday's lesson. Okay, so this is where I give you a statement and I want you to form the equation. And this actually wants it in standard form. Okay, so make sure you read your instructions for it to tell you what it wants you to do. And if you look, it says standard form. Okay, right here. All right, now this one tells me my leading coefficient is 1, so I don't have to worry about solving for a. Okay, and then it tells me my zeros are these 4 zeros right here. And it's a quartic function, which means there are 4, and it gives me 4, so I don't have to worry about any multiplicities. Okay, so we write it in factor form, and then we're going to multiply it out to get the standard form. Okay, so I have first write it in factored form. Remember when you plug it in, it's opposite. So it's going to be x plus 5, x plus 2, x minus 5, and x minus 6. I'm going to box the 2 little ones in like the pairs. So you come over here. So the first 2 multiply to give me x squared plus 7x plus 10. The second 2 multiply out. And that gives me x squared minus 11x plus 30. Then I'm going to factor or pull those 2 out. So I need a 3 by 3 on this round. Make it big enough. X squared 7x 10. So pull these out, and this top right corner here gives you your degree, which is a quartic, which is 4. So we're good. So 7x cubed, 10x squared cubed. Squared. Let's see. So I'm going to give us big numbers. All right, so then we're going to pull out from there. I get x to the 4th. Then I've got my cubes right here. That's negative 11 plus 7. That's going to give me negative 4x cubed. And then next we have our squares. So that's going to be 30 minus 77 plus 10. And that's going to give me negative 37x squared. And then I have my linear term I have left. These 2. I'm going to add those together. So I have 210 minus 110. Well, it's easy. So that's going to be plus 100. X, and then just your plus your 300. So my final answer I would type in here, x to the 4th minus 4x cubed minus 37x squared plus 100x plus 300 would be your answer. Okay? All right. Given my math is right. All right, so next one. This one wants you to get it from a table, so you need to remember from Math 1 that when you look at a table, so to write it in standard form, we have to start in factor form. And in factor form, you need your roots. So you need your roots, which are your x-intercepts, right? And your x-intercepts, you know you can find them from a graph by looking where they cross your x-axis. To find them by looking at a table, your x-intercepts are where y equals 0. So wherever y equals 0 is where we have our x-intercepts. So if you look, I have one here, okay? No, sorry. So when y is 0, Lord, help me. There's when y is 0, there's when y is 0, there's when y is 0. Now, it told me I needed a cubic function, and we know a cubic function is a degree of 3. So when I look at this, do I have 3 zeros by looking at the chart? I do. So that means I'm good to go. Let's go ahead and write our in factor form. So you still change your signs. So I've got, now this one does not tell me my a, so I'm going to have to solve for my a, okay? So y equals a, x plus 3, x minus 2, and x minus 3. Now, I can pick any of these values to solve for a. It's multiple x and y's, but I'm going to do the easy one where x is 0. Saves me some brain power. So 18 equals a times 0 plus 3 times 0 minus 2 times 0 minus 3. So that's going to give me 3 times negative 2 times negative 3. So 18 equals a. I'm going to multiply those out. And I get 18. Then I'm going to divide by 18. Okay, so a equals 1. So I really don't have to do anything because a is already 1. And 1 doesn't do anything to the equation. So now I can just pull those out. All right. So I'm going to erase. All right, so we solved for a. We found a was 1. All right, so we already found that a was 1. So I can just continue on with what I had. All right, I'm going to factor these two in. Okay, so those two are going to be x squared plus x minus 6 times x minus 3. Then I'm going to fool those two. So I need a 2 by 3. All right, so my answer, when I pull it out, is going to be x cubed minus 2x squared minus 9x plus 18. Okay? All right. So that's when you have a table. So the only new information here was how to find your zeros by looking at the table, and that's just when y is 0. Okay? All right, last one we're going to do together, okay? So it tells me it's a quadratic function. So a quadratic function means there's 2 solutions, okay? So a quadratic function means it has a degree of 2. And it gives me 2 zeros, so there's no solving there for those, okay? Or no, you don't need any extra multiplicities. It tells me the y-intercept is 30. Now, you need to know the y-intercept in coordinate form. The y-intercept is when x is 0, okay? So it's going to be 0, 30 is my y-intercept in coordinate form. That's going to help us solve for our a because it doesn't give us our a value. And it wants it in standard form. So I first write it in factored form. Y equals a x plus 2 times x minus 5, excuse me. All right, I got to solve for my a, so I'm going to use these two numbers over here as my x and my y. So my x is 0, my y is 30. So that's going to give me 2 times negative 5, which is 10. Divide by 10. And a is going to be 3. Okay? So now that I know my a is 3, you're going to distribute that last as we've talked about. Okay? So first you need to fold those two guys. So when I do that, I still have the 3 on the outside, and I have x squared minus 3x minus 10. Now we're going to distribute that 3, and my final answer is going to be 3x squared minus 9x minus 30. Okay, and you would just type that up here in the answer box. All right, so that is it for today's Delta Math Explained. But if you need more explained, send me a picture of your problem. I'll help you solve it. Or as always, Delta Math can show you how to do it with the show solution. Okay. When you do theirs, sometimes it's really good. They go really in depth with it. I mean, I did too, but it might help you. Okay. So don't forget to use all your resources you have. And as always, I am here and available as one. All right. Have a good day, guys.